Okay, hello everybody. Global economics and yeah, interesting days after the vote in the United States, and we will see what the implications for the global economy will be if Trump is taking the lead in the United States. Well, we today want to start a view from a more theoretical point on the economy, and for this I want to do with you a short revision of the so-called ISLM model, and we will have a look at this model from a little bit more theoretical way than I've done it in macroeconomics, and then we want to go into more detail for the implications of monetary policy, because this will be also quite interesting with respect to the vote in the United States, because I assume that the question of independency of the central bank in the United States we have to pose, and later on we will also go on to a direct model of how a central bank acts within the economy. Yeah, but we start with the ISLM model, and I think you hopefully remember that we there have a look at two markets simultaneously, the goods market and the money market. And at the goods market, we make the assumption that investments equal savings, and this is the reason IS, where the name from the model is coming from, I for investment and S for savings, and this translates in our equation we had that we said overall demand. We are looking from the demand side on the economy, overall demand YD equaling consumption plus investment plus government expenditure equals total income or total production equaling Y. And this we can rewrite to Y minus C minus G equals I. And this is, so to speak, our private and public consumption. And then if we subtract from total income total consumption, what do we get? What is this general decision which we make when we say, well, let's say we have 1,000 euros per month. What is then our general economic decision, what we are doing with these 1,000 euros? It's okay. Uh, well, we have income, 1,000 euros per month, or total income in Germany, roughly 4 billion euros a year. Then we make the decision that one part we directly consume and the rest we are saving. So this is saving and this is investment. And do you know what we are roughly saving? Which margin we are saving? In Germany and roughly in developed countries? What is the saving ratio? Do you remember this? Yeah. 5%? 12%, yeah. For Germany, it's roughly 12%, but 5% would be quite good for the United States. They are not saving that much. Because why? Well, they get a credit from everywhere since they have the main currency in the world. We all need US dollars, so the United States can go everywhere and ask for money. But in general, we could say roughly 10%. This would be on average a good number for developed countries. Yeah. Okay, so these are the main equation for the goods market, and on the money market we just write down money supply equals money demand, and money supply is given very easily that we more or less say the central bank supplies the money, but we have here also to introduce that we are talking about real money, so we are dividing the nominal amount of money, capital M, over the price level equals money demand. And there, remember it from the transaction motive, from the precautionary motive, and from the speculative motive, or if you just say the argumentation via opportunity costs, that money demand is depending on total income, and there it is positively depending on total income and negatively depending on interest rates. So these are then the two main equations within our model, and this I gave you. Oh, it's not working here. Oops. No, it's going here. In more detail on the next slide. So we are going to the goods to the commodity market, and as I already told you, from the budget restriction, Y equals consumption plus investment plus government consumption, and there we also assume that consumption is positively dependent on consumption and investment is negatively depending on interest rates, since this is the nominal interest rate and then of course subtracting inflation we are coming to the real interest rate. And here also we can argue from the opportunity cost principle, the higher the interest rate, the more costly is the credit, and therefore we have a negative dependence of investment on interest rates. Yeah, and if we take this together, then we obtain from this a dependence between income Y and interest rates I. And we have done this with direct calculation, giving the functions, or from this graphical point of view. But of course, we can also do this directly calculating the total differential. So we are varying our income with respect to the two endogenous variables y and I. So this is the total differential, and the total differential is defined as the sum of the partial derivatives with respect of our endogenous variables times the change of the endogenous variables. So hopefully you remember, if you have a general function f of x1 and x2 equals y, then the total differential dy is the partial differential with respect to the first variable times the variation of the first variable and the first derivative with respect to the second variable with times the variation of the second variable. And in our case, we have x1 equals y and x2 equals I. Oops, there's a typo. This has to be I. Sorry. And what we then have is this equation. And then remember, this is nothing else than our marginal consumption. And for the marginal consumption, we of course assume that this is a number between 0 and 1. And if we go back to the slide here, well, then marginal consumption will be roughly 1 minus the savings ratio. So in Germany, we could say it would be roughly 0.9. Yeah, and if we now take this part on the left side, then let's do this calculation. We obtain dy minus dc over dy equals di over small I di. Then we can take out the brackets, out of the brackets dy, and dividing by dy, we obtain then for the dependence between interest rates and income 1 minus marginal consumption over the first derivative of investment with respect to interest rates. Well, this here is a number between 0 and 1. This means 1 minus a number between 0 and 1 has to be a positive number. And here we assumed the higher the interest rates, the lower investment. Therefore, the first derivative has to be a negative number, and then we are dividing a positive number by a negative number, and this result is that we have to have a negative number, and therefore we have derived that the IS curve, dependence between interest rates and income, has to have a negative slope. So then dependence between investment and income has to be negative. Yeah, and when we are going to the money market, this we had also already on the former slide. Again, we assume positive dependence on income, negative dependence on interest rates, and then we assume that money supply, real money supply, has to meet money demand. And for this also we can calculate the total differential from this equation. And real money supply is exogenous, is a fixed number. This we assume is given by the central bank. So then the variation of a fixed number is what? Well, if it's fixed, what is the first derivative of a fixed number? If we maybe say f of x is 3, this would look like this. What is then f prime of x? 0, of course. So we obtain on the left hand side 0, since we assume that money is given, and then writing the definition of the total differential, we have to calculate the derivatives with respect to y and I. So dy I times the variation of interest rates plus, no, not dy, sorry, money demand, and dld dy dy. So, and this we can also solve. Solve for di over dy, as we did it here for the commodity market. So then we obtain, putting di on the left hand side, is minus dl with respect to I times variation of I. So we obtain di over dy equals minus, and the first derivative with respect to y divided by money demand derivative with respect to interest rates. Well, and here also we take our assumption plus dependence on income. So we know that this number has to be positive, and negative dependence on interest rates. So we know that this number has to be negative. And then what can we say, which sign has this expression overall? When we have here plus, minus, and here minus, what do we obtain for the sign of this expression? Plus, of course. So this minus and this minus cancel, so to speak, to plus times plus is larger than 0. Well, and this then means for our LM curve we have to have a positive slope. So from money market we obtain a positive dependence between interest rates and income. Well, and now, so to speak, we have theoretically derived what we derived on a graphical way in our macro course. Here is the derivation of the positive dependence for the LM curve, where we said, well, here we have money demand, money supply, and here money demand, and then we said we started at some initial income y0. This gives an equilibrium interest rate at the cut of money demand and money supply. So we obtain one first data point for the dependence between interest rates and income. And when we then increase income, so y1 is larger than y0, then the demand curve shifts outwards, and then we see that for a larger income we have also a larger interest rates. This we have to do for all incomes, and then we also obtain this positive dependence. And here for the IS curve I have done it analytically. Let me just also redo it for the IS curve in the graphical way. There we had YD and Y, the 45-degree line. YD equals C plus I of I plus G. YD equals Y, and then for a starting interest rate we had one first, income, and this we can draw downward in the interest rate income diagram. So this is y0, and let's assume that I1 should be here, so we would have our first data point here. And now if we increase interest rate, what happens then in the upper diagram? If we want to draw now YD for a larger interest rate, what happens then with this curve? Well, remember we have the negative dependence on investment. This was more or less cy, c0, cy times y. So this here is c0 plus I plus g. What happens with investment when we are increasing the interest rate? Which relation I have to put in here? If I1 is larger than I0. Well, if the costs of your credit are increasing, are you then investing more or less? Then you of course invest less. So then investment is going down, and if this number here is going down, we obtain a parallel shift downward for YD, and now equals C plus I of I1 plus G. So I1 is larger than I0, and here we obtain a smaller equilibrium income for I1, and then this we have to redo for all interest rates, and therefore we then obtain these negative dependence, which we have also derived analytically. Well, and together with this, we put both markets simultaneously together, and then of course we obtain the overall equilibrium when the two curves IS and LM curve are cutting here in the middle. Okay, and now I will also do with you the general analytical solution of our model, which we only have done with explicit functions or in a graphical way in our introductory course. So what we now want to do is analytical solution for monetary policy and fiscal policy. Well, let's start with monetary policy. What does this mean? This means now that when we are changing in the central bank the amount of money, then a change is then of course not zero anymore. So now we make this exogenous change. Since I will do this also for fiscal policy, let's copy this one. And taking total differential of both equations with dm not anymore equaling 0. So then what we obtain is dy equals dc over dy plus di over I di. This is from the commodity market, and from the money market now we obtain dm equals dl dy plus dl di di. Well, and what we here have now is a system of two linear equations with our two endogenous variables, interest rate and income. And what we can do is then that we rearrange our system of two equations so that we then analytically can directly solve this system with the aim that we want to obtain the dependence of the how much the income is changing if we are changing money. So therefore we collect in the commodity market all terms with dy and all terms with di. So the first one would be then, and this we had already done, we have already done 3 slides before. This was this calculation here. That we obtain 1 minus dc dy times dy on the left hand side minus di over I times di is 0. So we are putting these two terms on the left hand side. And from the money market what do we obtain? There we have not to redo anything because everything is already collected in the right way. We have here the dependence of the income, the change of the income, and here the dependence of the change on interest rates. So we obtain here dl over dy times dy plus dl over di times di, and now we have here not 0 but the exogenous change of real money supply. And maybe or hopefully you remember how we can now solve this system. We want to solve for dy over dm. This is what we want to do. And maybe you remember, if you have a system ax plus by equals 0 and cx plus dy equals e. If you want this, solve for x. What you are doing then? Maybe let's take capital letters that we do not confuse it with the other. Oops. Oops, this one too. A, B, C, D, and E. So A, B, C, D are just numbers. This is just this linear system. How can you solve this? Well, we have to somehow cancel out the variable y. And for this, in front of y, we have to have the same numbers. So here we have a d in front of y and here a b in front of y. And how can we manipulate these equations that in front of y we have the same number? Let's take this in colors. Red. Well, then we just multiply the first equation with d. 0 times d is of course still 0. And the second equation? Times b. Definitely right. So b, 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 and what we are doing then, in order to cancel the part with the y, oh, they are not equal. Here you have a 0 and here you have be. Well, we just subtract these two from each other. And what we then obtain is, let's take this in black again, is dA minus BC times x. Here we have the same, so then we have a 0. equals 0 minus this part is minus BE, and then we obtain x is minus BE over dA minus BC. And these are all known numbers. And the same thing we are doing now with our system here. So we could identify A with 1 minus marginal consumption, B the parameter dependence of investment relative to interest rates, C dl over y, and D dl over I, and E is dm. So here we are then multiplying with dl over di, and this one we multiply with di over I. And then we obtain 1 minus dc dy times dl di minus di di dl di, here I missed dy di equals still 0, because 0 times any number is still 0, and the other one is dl dy times di di dy plus dl di times di over I. di is now di over I times dm. Yeah, what we are now doing is, since we have here a minus and here a plus, we are not subtracting both sides, but not sides, but both equations. But what we are then doing, not subtracting 1 minus 2, but since we want to get rid of the interest rate, yeah, what? Yes, yeah, for sure. We just add these two up. So here plus both, and hopefully I have enough space, and then we obtain 1 minus dc dy times dl di plus dl dy times di over I times dy. This one, if we take plus, cancels just out, and here also plus equals dm times di over I. And then we obtain dy over I is just not over dm. This is what we are aiming for. So dividing by this and dividing by this part, and hopefully my digital competences are enough. Copy, paste. Then I have this one and copy, paste. I'm really proud of myself. And oops. Oh. I just moved. Why? I don't know. So, and this is then our result. So this looks quite complicated, but if we look now inside what we have here, then we see what is the sign of this derivative. How is investment changing if we are changing interest rates? What is the sign of this expression? So you have to think about how is investment changing if interest rates are rising, for example. Interest rates go up and then investment is going down, and therefore the first derivative has to be so I is increasing and small I, interest rates are increasing and investment is going down. This means for the first derivative this we had here. Or even we had it oops here. This is here our minus sign. And therefore this has to be negative. So marginal consumption between 0 and 1, again this part 1 minus a number between 0 and 1 has to be positive. Money demand on interest rates from opportunity costs or from the speculative motive, we also had the negative dependence. Money demand with respect to income, the richer we are, the more transaction we want to do, the more we want to buy, the more money we need. So we have assumed positive. Again, investment depending on interest rates, negative. So here we have a positive number times a negative number is overall which sign? So these two together. This is negative, great, and here also a positive and a negative number times a negative number is negative as well. And a negative number plus a negative number is then, here we are adding up two negative numbers, negative as well. And now we are dividing a negative number with a negative number. This means overall the right side has which sign? Negative over negative? Positive. Great. So, well, and this is hopefully not very surprising. This means if we are increasing real money, then this would push our economy. So the change of y with respect to an increase of real money will also increase y. This is then, from an analytical point of view, what we would also, just from a qualitative argumentation in an economy, what we would expect. But now, well, I know it is, I don't know if you have seen something like this in other courses, but this is then just the analytical derivation of this general result, that the central bank in general could push the economy if we are increasing money supply. Well, and now I think we could go a little bit faster. We have 15 minutes left. That we now redo the same calculation. Now, not for monetary policy, changing the real money, but fiscal policy, just exogenously changing government expenditure. So now we are looking at fiscal policy. So I think I can just write down this linear system directly, just exchanging here a 0, because now we are not changing money supply, but here on the right hand side dg as the change for government expenditure. So then we would have dc over dy, 1 minus, times dy minus di over I times di equals now change in government expenditure. So now dg is not 0 anymore, and here we had dl dy minus dl di equals 0. And now we want to solve this system. What we have then to do? Again, we want to get rid of the interest rate part. So we are interested in dy over dg's. So how much is income changing when we are changing government expenditure? And this means we have to cancel out di. So the part in front of di in both equations has to be the same. What we have to do?
Is it not the same?
It is. No, it's not. It's here I, and here we have L.
Then the term, the first term is L.
Yes, great. So with the derivatives, of course, no? But I think you meant this. And this one with di over di. So then we again obtain 1 minus dc over dy times dl di dy minus di over I dl di di is now dl di times dg, and here dl dy times dl di di times dy plus, sorry, this was a plus, di di dl di di, and this is now 0. Then again, adding these two up, this means the part with the interest rate is canceling out, and we obtain 1 minus dc dy dl di plus dl dy di di times dy is now dl di times dg, and we want to solve for dy dg, and this equals now copy, sorry, and the other way around, sorry. No, this is right. So dl di. Well, of course, then we have the same argumentation as before, that the nominator is negative overall. This has to be negative, since that is plus, minus, plus, and minus. And again, now the only difference with this is that in the denominator we have not the derivative of interest rates, of investment with respect to interest rates, but money demand. But also for this number we have assumed that from the speculative motive or opportunity cost, that this is also a negative number, and then overall negative divided by negative is positive, and so also we obtain in general a push of equilibrium income if we are increasing government expenditure. So, for the last revision, I think I planned just to do one example. Yeah, and then of course we can also, if we look for monetary policy, and for the monetary policy aspect we want to go now into more detail, that from a graphical point of view, what would mean an increase of m. So if m is going up, this means that the LM curve is shifting downward, and then of course we obtain this increase by the new cut of the IS and LM curve for equilibrium income. Well, and this, of course, we can also qualitatively argue how this functions, increasing M, right shift of LM. And this means now that if we are still looking at our starting income, that now this corresponds to a lower interest rate. But then we have the feedback to the commodity market. If we have lowered the interest rate, then this feeds into the investment function on the commodity market. And for this we have argued quite often today. Lowering interest rates means an upgoing investment. But an upgoing investment means, since overall income is consumption plus investment plus government expenditure, means that one part investment is going up, that then also overall income has to go up. So lower interest rates, this is the feedback of the money market into the commodity market, increases investment, and remember y is c plus I plus g, and if this is going up, then also this has to go up. Okay, then I think as a homework for you, I want you for next Monday that you, just try to do this little example where I directly gave you explicit functions for the investment function, consumption function, and the money demand function, and then you should calculate what is the impact if we increase money supply by 5%. So you can assume also here that prices will stay at P, price levels will stay at P equals 1. Yeah, okay, then thank you very much for today.